Hello everyone, welcome back to our review of Pre-Algebra for College Algebra, and today we'll be talking about radical exponents. So, if you remember earlier, we know what exponents is. They can be x squared, x cubed, x to the fourth, etc. So, we also know what a square root is. And there's also cubic roots and all roots. So just like square roots, meaning that we would want a number, well, b times b equals x, here we would want 3b's to equal x, then 4b's to equal x. So, what if we want to express one of these as an exponent? Well, we have a formula for radical exponents. We have a to the m over n equals n to the am. As you see, top goes with inside, bottom goes with outside. So we take the square root of x. It is known that there was understood 2 and understood 1 there. So this means that we can write the square root of x as x to the 1/2. As you see, we have inside top, outside bottom, just like the formula from above. So let's take an example. Let's take 512 to the 5/7. Well, inside or top inside, bottom outside, and there is the radical exponent expressed as a radical. So now let's take a counterexample, 3/9 to the 10th, and let's express this as a radical exponent, where we know we have top inside giving us 9, 10/3, outside bottom over 10/3. So that is the radical exponent. So again, this has only been for real numbers so far, but let's try to express this as a variable. So let's have 12 x to the 7th. Just the same rules will apply. So we have x, then we have inside top, then we have outside bottom, giving us x 7/12 as the exponent for the radical. So again, for another example, let's have b over 4 to the 3 and express this as a radical. Well, we have outside, we have top inside, bottom outside. Alright, so that's pretty simple, and it's a pretty simple formula. So, if you notice, b to the 4/3, this is still an exponent. So that means all the rules we talked about previously for exponents still apply for radical exponents. So using that, let's try to simplify this example. So let's have 3/4 y to the 1/2. Let me make that a bit more clear for you. Y to the 1/2 times y to the 3/4 times 7y squared. So first, let's separate the real numbers and the variables. For the real numbers, we have 3 times 4 times 7. And for the variables, we have y to the 1/2 times y to the 3/4 times y squared. For the real numbers, we just have to multiply, giving us 84. And for the variables, again, we just multiply. You remember when we multiply exponents, we actually add the exponents. So this is equivalent to y to the 1/2 plus 3/4 plus 2. When adding fractions, we need common denominators. So we need to make 1/2 times both the top and bottom by 2, giving us 2/4. And 2/1 times 4 on both the top and bottom, giving us 8/4. That means the above expression here can be expressed as y to the 2/4 plus 3/4 plus 8/4. By adding the numerators, we get y to the 13/4 as the simplified variable. If we put the real number and the variables together, we'll get 84 y to the 13/4, and this is the simplified expression. Alright, now let's move on to another example. Let's have 25/100 to the negative 1/2. Or if you remember the exponent rule, x to the negative 1 equals 1/x, we flip the numerator and denominator. So we'll do the same thing here. So let's take 100/25 to the 1/2, And that was achieved by just flipping the top and the bottom. So now there's two things we can do. First, we could reduce. 25 can go to 100 4 times, giving us 4 to the half, giving us 4. The square root of 4, giving us 2. Or we can use the quotient rule. So we can go the square root of 100 over 25, square root of 100 over square root of 25 by the quotient rule, giving us 10 over 5, 2. Either way works as long as you get the right answer in the end. Alright, so now let's move on to the last example for today's video. So first we're going to have 64 times b to the 1/3 power times 21 times b to the 2/3 power times b to the 4/3 power. So first, we must move the 1/3 inside the parentheses to both 64 and b. So you have 64 to the 1/3 power, b to the 1/3 power, 21, b to the 2/3, b to the 4/3. If we separate the real numbers and variables, we can have 64 to the 1/3 times 21. And as the variables, we have b to the 1/3 times b to the 2/3 times b to the 4/3. If you type into your calculator 64 to the 1/3 power, you get 4, giving us 4 times 21 equals 84 as the simplified real number. Now moving on to the variables, using the power rule, we have b to the 1/3 plus 2/3 plus 4/3. And since we already have common denominators for the fractions, we can just add it across, giving us b to the 7/3. By putting the variable and the real number together, we'll have 84 times b to the 7/3 as the simplified expression. Alright, that's going to be all for today's video. Thank you for watching.